In this video, we're going to look at rationalizing the denominator, which is really just the method you use to divide radicals. And here's the hint. It's a lot like trying to add or subtract fractions. What you're going to try to do is you're going to try to multiply top and bottom by the same values so you don't change the original value of the problem. And so we're going to multiply top and bottom by the same number, but we're going to choose that number very carefully. And we're going to have to know our rules for roots and exponents and which cancels which. Okay, let's go ahead and get started. Now here I have a separated out radical. My first thing that I tend to look at is, can I cancel anything out? In order to ascertain whether I can or not, I have to recombine. And so we have a rule that says if you have the nth root of a fraction, then you can split that fraction into a fraction of the nth roots. You can also go the other way, meaning that since I have a split, I can recombine them under the same square root. I'm doing this to see, can I cancel anything top and bottom? In other words, can I reduce the fraction? And unfortunately here, 2 and 3 don't share a common factor and only x is on top. So I can't really do it. So I'm going to re-separate them. But this is a good thing to look at, because if you can do that, your numbers become smaller and easier to manage. Okay, so now that we've checked that, I'm going to go ahead and bring this down so that I can work with our next step. Now, in order to multiply the stuff inside, because remember I have to be working with these inside numbers. In order to do that, I can only work with radicals of the same index. And we have another rule that we should have learned that says that if I have a radical and I'm multiplying inside, I can split that multiplication up into individual radicals. That also works the other way. And so when I do that, in order to multiply into these, I'm going to have the same radicals. That's what this says. I have to have the same index if I want to multiply and combine. Well, I have to have the same index, and that index here is 2. The choice that I do, or the choice that I use, or the number that I use to make my choice, is the denominator. We are rationalizing the denominator. And so everything is based on the denominator. The denominator is a square root, so I'm going to multiply top and bottom by a square root. Remember, it has to be the same number because the effect is I'm multiplying by 1, not changing the value. All right, and so we need to choose. Well, I have 1, 3 over here. I need to have groups of 2. So how many more 3s do I need? And the answer is I need 1 more 3. But I have to put that top and bottom. Okay, the question I asked myself was, I have 1, 3 here. How many 3s do I need? How many more do I want? That's how I asked myself that question. Because when I multiply across, I'm going to multiply the 3s together. Those exponents are going to add. Let me get rid of some of this junk. Whoop. I just want to get rid of some of the stuff on there. Okay, so now that's how I made my decision as to what I'm going to multiply by. First thing is, look at the denominator. I just tell my students, go ahead, look at the denominator, multiply by the same radical, or by the same root top and bottom. Before you put anything in those roots, just go ahead and do that. Then decide what goes inside the roots. Okay, so let's go ahead and multiply this out. This is going to give us the square root of 2x times the square root of 3, divided by the square root of 3 times the square root of 3. If I do that, then I can multiply the radicands inside. And so this becomes the square root of 6x, because 2 times 3 is 6. Down on the bottom, it becomes the square root of 9. Except that the square root of 9 is 3. And I can't take the square root of 6x or y. That's it. That's the answer. Notice that you have a rational number on the bottom, so you have done exactly what we set out to do. You have rationalized the denominator. That's division of radicals.